everyone, my name is Liam. I'm a data scientist who worked in experimentation at Booking.com and Meta, and today I run an experimentation consultancy where we give trainings and workshops on experimentation and statistics, and I help teams build experimentation tools. Today we'll be discussing how to measure the gains of your tests using retesting. So just to give an agenda, first we'll define what exactly we mean by gains. Next, we'll move on to why do we even care about measuring gains. And finally, I'll explain how to measure your gains using retesting. So, what is a gain? Well, to start, I'd like to use an analogy of a casino. On the one hand, you can determine, did I win? So let's say you pull the lever on a one-arm bandit and you get all matching sevens, then you can say, I won. But on the other hand, you also want to know, how much did you win? How much money came out of the machine when you got those matching sevens? That is what I'm referring to when I say gains. Essentially, how much did you win? And this also applies to A/B testing. So on the one hand, you can test the statistical significance of your change. That's your p-value, and in many UIs, when your test is statistically significant and positive, the results will be shown in green. And what this tells you is that your change had a positive improvement. But on the other hand, you may also want to know, how much of an improvement did I have? How much did it improve conversion? And in this example here, it's shown on the right. Here we see there was a 14.4% improvement in conversion. And again, that 14.4% is what I'm referring to when I'm talking about gains and measuring gains. So to put it simply, gains are the size of your win, and that's what we're going to be focused on. So the next question you may have is, why do we care about this? Why do we want to measure gains? Well, there are many use cases for measuring gains. First is prioritization. There's a lot of things you could potentially work on, a lot of directions to take your product, a lot of UI elements you could work on improving, and you need to decide which of those is worth your time. So a common way to do this would be, let's say, over the last year, you've ran 5 tests on the landing page and you saw a net increase in conversion of 10%. And when you ran changes on the customer service page, you only saw a 1% increase in conversion on average. So based on that, you could decide, okay, I'm going to focus all my efforts on the landing page improvements. Next, there's a cost-benefit analysis. Let's say you want to switch the payment provider of your website, but that provider has higher fees. But that payment provider also has a higher success rate, which leads to an increase in conversion. So now you need to make a trade-off between those higher fees versus that increase in conversion. You now need to know how much did it increase conversion to know whether it's worth going with that payment provider. Another example is performance metrics. Often we want to set targets or goals for teams based on how much they increased a metric, for example, conversion. We could say, Team A, your goal is to increase conversion by 1% this year. And then that will determine how you incentivize and rank the success of your teams. Finally, there's strategic and financial planning. A company may wish to know how much they can expect to increase revenue for the next year, and this could be based on, historically, from experiments run over the last 2 years, they've seen they've been able to increase revenue by X, and therefore we think it's reasonable to expect a similar increase going forwards, and this could inform budgeting and financial decisions. So I've just described the use cases for accurate gains measurements, but what are the consequences of inaccurately measuring gains? For one, you could misallocate resources. Maybe you put funding into teams or product areas where you expect you're getting a high return, but in reality, you're not getting the return you should be getting, and you've actually diverted resources away from other more potentially valuable areas. A second case could be reduced ROI. Let's say you're overestimating the gains you're thinking you're getting from marketing, and this determines your budget spend and your marketing spend. So maybe you're overspending and your actual ROI is lower than you think it is. And all of these mistakes could result in a loss of credibility. Let's say you've been overestimating gains and you tell your stakeholder that there's a 5% increase in revenue, But how come when they look at the bottom line, they don't see that increase? All of this could result in them losing trust in experimentation, in data, and ultimately in you, the experimentation expert. Being able to accurately measure your gains is vital to the long-term success of companies. We've now established what gains are, why it's important to measure them. But now, what's the challenge? I mean, you run an A B test, we get the two values. We get the significance, the p value, the green tick, but we also get to the right of that here, the estimated change, a 14.4% increase. Why can't we just use that? It's the natural and intuitive expectation because you are seeing this estimate from your tool. The problem is something that we call the winner's curse. And to illustrate, I'll explain an example of job interviews. Imagine you're the hiring manager for a role. You want to find the best person to fill that role. So naturally, you'll interview lots of candidates. We all know that a candidate's interview performance on a given day is not set in stone. Some days they may perform poorly because, for example, they didn't sleep well, while on the other hand, they may perform well because they had a fantastic breakfast. In other words, a candidate's performance in the interview is varied. There's random noise around it. There's a very high chance that the person you selected just happened to be overperforming on the day of the interview. And when they actually come to fill that role, they may not perform as well as you expected. It doesn't mean they will be performing badly. It just means there's a very good chance they won't perform quite as well as you thought they would. And it's an example of a selection bias because we are selecting. The act of selecting that best case introduces a bias. The same situation applies to A/B testing. For any change you make, there is a true gain. The actual increase in conversion you'll experience if that change goes live. That true gain is unknown, but in order to estimate it, we run tests. There's also random variation around the gain measured in each test. So sometimes a test will tend to underestimate the gain. This is just through random statistical noise. And sometimes the test will overestimate the gain. Again, this is just due to random chance. But the issue is, we are more likely to call a change a winner when the gains were high. In essence, we are more likely to call a change a winner when we overestimated the gains. There's an actual case study from Airbnb where they measured the gains from 6 actual experiments and they added them all up. And according to that, they would have expected to see a 7.2% gain. However, when they used another technique to estimate the gains more reliably and accurately, they actually measured the gains were only 4%. So, in other words, this winner's curse resulted in an 80% overestimate of the gains. And based on personal experience, I have seen cases where this winner's curse has even resulted in tenfold increases in the effect size. We overestimate the gains for winning tests simply because if we didn't see a large gain, then we wouldn't have called that test a winner. We have established this problem. Let's explore some methods for mitigating it. How do we accurately measure gains and avoid the winner's curse? There are quite a few methods for doing this. One is holdouts, which is the method used in that Airbnb example. Another is haircuts. We're not going to go into any detail on these really. I want to focus on retesting because I believe it is the simplest and most widely applicable method. What is retesting? In a nutshell, it's just repeating your experiment. You ran a test, you had a winner, and then you just reran that test straight away afterwards. What's really great about retesting is that it's simple. You don't have to change the settings of your experiment at all. You just rerun the test exactly as you ran it originally when you declared it a winner. And then from the second test, this retest, we just take our gains measurement from there. Remember, the issue was it's a selection bias. By selecting a winner, we tend to overestimate the gains. So the key with retesting is that We are decoupling the decision from whether a change is a winner. Essentially, the gains measurement is not impacted at all by the decision of whether or not something was a winner. Because we're good experimenters, we would only call a change a winner if it was statistically significant. Now, what happens if your retest, maybe on your original experiment, you measured a 5% statistically significant increase in conversion, and now on your retest, you only measure a 2% increase in conversion, and it's not statistically significant? What do you do here? Do you consider that maybe your original win was a mistake? Can you not count the impact of the gains because it wasn't statistically significant? No. You should take your retest gains estimate whether or not it's statistically significant. It doesn't need to be statistically significant. And the reason for this, again, is that we are decoupling the gains measurement from the decision as to whether or not something was a win. The statistical significance is just what we use to make a binary yes-no decision. Was this change a win? Let's say you saw this fantastic gains, the stat sig result on your original experiment, which you then didn't see on your retest. It's very natural to wonder if maybe your original test was a mistake. In this case, what I would suggest is don't use your retest to then decide to disable your win, to maybe call your win a loss, but rather run a follow-up experiment to retest again whether that change was stat sig. The winner's curse affects everyone, even companies that are really great at experimentation like Airbnb. So what do you do if the retest shows very different results to your original experiment? What if your original experiment showed really high stat sig gains, but then your retest showed very low gains? Should you then disable your win? No, the key is not to panic. It's okay to maybe pause your win whilst you do further investigations, but remember, the key here is to decouple decision making from the gains measurements. And if you decide to disable win purely based on the retest, you are therefore no longer decoupling those. You're using your retest to make a decision about whether or not a change would go live. So rather, what I would suggest is maybe pausing your win for now and doing some further investigations to understand what could be happening here. Do a post analysis, search for bugs. Maybe it could be seasonality. The key is to come up with some hypotheses to figure out what could be happening. But ultimately, if you then want to get confidence into whether or not your win should really go live, what I would recommend is a third test. And use this third test really just to look for statistical significance. Is it a statistically significant improvement in your key metrics? If yes, keep your change live and then just take the gains measurement from your second test, your retest, your original retest. Another kind of caveat to this retesting topic is how do you combine gains across multiple tests? So the short answer is that you can add up gains from individual tests, but this has some problems. It ignores factors like cannibalization, like interactions between changes. So it's not a perfectly reliable estimate of the overall gains, but it is a decent rough estimate. So what's the takeaway here? The takeaway is to measure the gains of your wins, you need to run a second experiment purely for the purposes of measuring the gains. So in summary, to accurately measure the gains of your wins, you should retest those experiments, and that'll help you make the smartest long-term decisions for your business. I'm Liam Furman. You can reach me on LinkedIn or liamfurman.com. Thank you very much. Goodbye.